The factory was alive again, yet Germany's war machine was still suffocating. At Leuna, shattered pipes were replaced, broken pumps reconnected, and production units coaxed back into motion. Then the bombers returned. German engineers could repair almost everything they saw, but they could not repair time itself. That was the contradiction confronting the Reich during the final year of the war. Its largest synthetic fuel complex repeatedly rose from the wreckage, only to fall silent again. Each recovery consumed workers, spare parts, railway capacity, and materials already disappearing elsewhere. To Allied analysts, the pattern revealed something more valuable than a ruined factory. Germany's strength had become a trap. The country had built an immense industry capable of transforming coal into liquid fuel. That achievement had once protected it from dependence on imported petroleum. Now the same system concentrated irreplaceable processes inside a limited number of enormous plants. Why could Germany keep rebuilding Leuna, yet never restore the fuel system that depended upon it? The answer began inside a maze of pipes, compressors, furnaces, and high-pressure vessels. Leuna did not merely store fuel or refine crude oil. Its installations forced hydrogen into products derived from brown coal under extreme heat and pressure. The process demanded tightly connected stages. Coal had to arrive. Power and steam had to remain available. Gas had to be compressed, purified, circulated, and controlled. Intermediate products had to move through pipes toward further treatment. A plant could appear largely intact while one damaged junction stopped an entire production chain. This made Leuna a strange target. It was too large to erase with one clean blow. Wartime bombing was nowhere near that precise. Bombs scattered across industrial grounds, surrounding communities, rail lines, and open land. Many missed the most important equipment completely. Yet a synthetic fuel plant did not need to be flattened to become useless. A fractured steam main could idle equipment that survived untouched. A damaged electrical connection could halt pumps across another section. Broken pipework could interrupt the carefully balanced movement of gases and liquids. The visible crater was not always the decisive wound. The decisive wound was disconnection. German repair teams understood this immediately. They cleared debris, patched lines, moved machinery, and improvised replacements with remarkable persistence. Production repeatedly resumed, sometimes faster than Allied planners expected. That resilience initially seemed to challenge the entire bombing strategy. If Leuna could return after an attack, perhaps the bombers were spending aircraft and crews merely to rearrange rubble. But the Allied campaign was changing its question. The objective was no longer to destroy every building permanently. It was to force Germany into a repair race it could not win. A repaired plant had to operate long enough to repay the labor and material invested in its recovery. Repeated attacks denied it that interval. Workers who might have expanded production instead rebuilt familiar sections. Steel intended for other industries became replacement pipe. Rail wagons carried repair material, while the transport network faced growing pressure everywhere. Air defenses, smoke generators, decoys, and thousands of personnel were tied to protecting one industrial complex. Each measure helped Leuna survive. Each measure also consumed another part of the system surrounding it. This was attrition measured not simply in destroyed machinery but in interrupted days. Before the sustained oil offensive, German planners could treat repair as a temporary response. Damage occurred, specialists restored the plant, and output returned. After the attacks became recurrent, repair itself became the plant's dominant activity. The factory was no longer only producing fuel. It was consuming Germany's shrinking industrial strength to preserve the possibility of producing fuel. That reversal mattered because liquid fuel connected nearly every mobile instrument of war. Aircraft required aviation gasoline not merely for combat but for training. Armored formations needed fuel before they could maneuver. Trucks needed it to move ammunition, food, and replacements. A tank completed in a factory was only potential power. Without fuel, it became stored metal. Leuna therefore exposed a weakness far larger than its own perimeter. Germany could continue assembling weapons while losing the ability to use them effectively, and the first great shock was still ahead. When the bombers returned in force, the question would no longer be whether Leuna's workers could rebuild. It would be whether Germany possessed enough time between raids for their repairs to matter. The sustained assault began on May 12, 1944. Nearly 1,000 American heavy bombers were dispatched against several synthetic fuel plants across Central Europe. Leuna was among the targets. The timing was significant. Allied forces were preparing to invade France, and German aircraft still threatened the coming landings. But attacking aircraft factories had produced a disturbing paradox. German aircraft production continued rising despite the bombing. Factories dispersed machinery, reorganized assembly, and replaced damaged workshops. Destroying airframes alone was not reliably destroying German air power. Oil offered a different approach. Every completed fighter still required fuel. Every replacement pilot needed repeated training flights before entering combat. Every tanker, railcar, and storage depot formed another link between production and the runway. The Allies did not need to destroy every German aircraft if they could starve the system that made aircraft useful. Leuna's vulnerability lay inside this larger calculation. It was Germany's largest synthetic fuel complex. But it was not an isolated miracle. It belonged to a network of plants converting coal into liquid fuels through expensive industrial processes. Germany had invested in this network because domestic petroleum resources were inadequate for a mechanized continental war. Synthetic production provided strategic insurance, but insurance works only while its critical machinery remains available. The May raid demonstrated that even scattered bombing could rupture enough connections to stop production. Repair crews immediately entered the damaged works. Their achievement was real. They restored equipment, replaced piping, and brought sections back online. This was no effortless recovery. Explosive remnants had to be cleared. Cratered roads obstructed movement. Utilities had to be tested before volatile processes could safely restart. Uncertain air raid warnings repeatedly drove workers away from exposed equipment. Some laborers were German specialists with years of experience. Many others belonged to a coercive labor system that included foreign workers, prisoners of war, and forced laborers. Their suffering cannot be separated from Leuna's apparent resilience. The plant's recovery was not simply an engineering triumph. It was also extracted from people working inside a dictatorship under bombardment and compulsion. Then another Allied formation appeared. Fresh damage overlapped with incomplete repairs. Components restored after one raid could be struck during the next. A substitute part might keep one production stage operating, only for an electrical failure elsewhere to halt the sequence. This changed the mathematics. Imagine a plant producing nothing for 10 days, then recovering partial output for 5. If another raid stops it again, the brief recovery does not erase the lost production. Repair speed may look impressive while monthly output continues falling. That distinction confused anyone judging success through photographs alone. Leuna did not have to resemble a wasteland. Its buildings could remain recognizable. Workers could still crowd its grounds. Smoke might even rise from functioning sections. The decisive measurement was fuel leaving the system. Across Germany's major synthetic fuel industry, production plunged after the offensive began. The decline was compounded by attacks on refineries and the later loss of Romanian petroleum as Soviet forces advanced. No single cause explains the entire fuel crisis, but recurrent bombing became a major mechanism preventing recovery. Allied commanders also learned an uncomfortable lesson. One raid was insufficient. Synthetic fuel plants could be repaired because many damaged elements were pipes, cables, valves, and exposed utility systems. Germany possessed skilled engineers and accumulated knowledge of each installation. If the Allies shifted permanently to other targets, production could return. The answer was repetition. Reconnaissance aircraft photographed repairs. Analysts studied renewed activity. Bombers were sent back after production resumed or reconstruction approached completion. The mechanism became cyclical. Bomb damage stopped interconnected processes. German labor restored critical links. Reconnaissance detected recovery. A new attack broke those links again. The factory's ability to heal now guided the timing of the next wound. Leuna's defenders responded by strengthening anti-aircraft protection, generating smoke, using decoys, and dispersing vulnerable functions where possible. These measures complicated Allied attacks and raised their cost. They could not remove the plant's fundamental dependence on connected, high-pressure industrial processes, nor could they create more hours between raids. By midsummer, Leuna was no longer fighting merely to produce fuel. It was fighting to complete repairs before the next formation appeared over central Germany. The plant had entered a race in which every visible recovery invited another attack. The obvious German answer was to make Leuna harder to find and harder to hit. Smoke generators could cover the complex beneath an artificial cloud. Decoy installations could pull bomb crews toward false aiming points. Anti-aircraft batteries could force formations higher, disrupt their approach, and punish aircraft crossing the target. None of these defenses was meaningless. Heavy cloud, smoke, navigation errors, and German fire repeatedly reduced bombing accuracy. Most bombs aimed at a vast industrial target still failed to strike decisive equipment. Aircraft and crews were lost. Bombs also fell beyond the works, killing civilians and forced laborers in surrounding communities. The oil offensive was never the clean surgical operation imagined by later mythology. Yet Leuna revealed why imperfect bombing could still create a systemic result. A synthetic fuel complex contained more vulnerable connections than an ordinary photograph showed. A near miss could rupture buried services or scatter fragments across exposed pipework. Blast could deform equipment without demolishing its building. Debris could block access needed by repair teams. Damage to power, water, steam, or transport could silence production units that had not received direct hits. The defenses therefore faced an impossible standard. They did not merely need to prevent Leuna's destruction. They had to prevent enough interruptions for the plant to sustain continuous output. Continuity was the resource. Germany was losing. Repair crews began working inside an industrial landscape shaped by recurring alarms. A section restored in the morning might be evacuated before afternoon work was complete. Replacement components had to be located, transported, fitted, and tested, while other German industries demanded the same scarce materials. Specialized labor could not be multiplied as quickly as damaged pipe. Experienced technicians had to diagnose complex failures across a plant whose normal operating balance had been repeatedly disturbed. Germany attempted dispersion and underground construction at parts of its fuel system. Smaller installations promised less concentrated vulnerability. Protected sites promised survival beneath rock or concrete. But moving a chemical industry was not like moving desks from one office to another. The process required heavy equipment, reliable power, water, transport, pressure vessels, and trained operators. Construction itself consumed steel, cement, machinery, and labor. Dispersal could reduce the consequences of a single strike. It also created new transport links and coordination problems when Germany's railways were coming under increasing attack. The countermeasure consumed resources before it produced fuel. This was the deeper Allied advantage. Germany had to defend every stage that might restore output. The Allies only had to interrupt enough stages often enough. One side needed dependable production, the other needed recurring disorder. Leuna became the clearest example of that imbalance. After its first major wartime oil attacks, the complex was struck repeatedly through the remainder of the conflict. Post-war investigators concluded that output between the opening attack and the war's end averaged only a small fraction of rated capacity. The exact monthly figures varied with definitions. Repairs and the products being counted, the overall direction did not. Each revival was weaker than the continuity Germany required. The consequences spread beyond the plant. Aviation fuel allocations tightened. Training hours for German pilots were cut drastically. New pilots could reach operational units with less flying experience, just as Allied aviators accumulated more. That difference could not be corrected by producing another fighter airframe. An aircraft factory could replace metal. It could not replace the hours a pilot had never flown. Fuel scarcity also constrained German freedom on the ground. Commanders could possess armored vehicles, but lack the gasoline needed for training, redeployment, and sustained maneuver. Reserves became harder to move quickly. Trucks competed for allocations needed elsewhere. Operational planning increasingly depended on assumptions about fuel that might never arrive. The Allies had not discovered a magical target that won the war alone. Germany was simultaneously losing territory. Petroleum imports, transport capacity, experienced personnel, and control of the air. Soviet advances deprived the Reich of Romanian oil during the summer of 1944. Anglo-American attacks battered refineries, synthetic plants, storage, and transportation. These pressures reinforced one another. That interaction was the real weapon. A damaged plant required trains carrying replacement material. A disrupted railway delayed those materials. Delayed repairs reduced fuel production. Less fuel weakened the aircraft, and vehicles protecting the railway and the plant, the domino chain had closed upon itself. Leuna's workers could still reconnect a pipe. Germany could no longer reconnect the entire system around it. The fuel crisis did not arrive at German headquarters as one dramatic announcement. It appeared through shrinking allocations, cancelled training flights, delayed movements, and vehicles ordered to remain stationary. Each restriction seemed temporary. Together, they changed what the German armed forces could attempt. The Luftwaffe felt the damage in two different timescales. The first was immediate. Aircraft could not fly missions without aviation gasoline. The second was delayed but more corrosive. Pilots who did not train adequately entered combat without the experience required to survive. By late 1944, Germany could still manufacture formidable aircraft. Its factories delivered fighters whose performance on paper remained dangerous, but production totals concealed the missing element. A newly built fighter represented industrial capacity. A combat-ready fighter pilot represented fuel already burned through many hours of instruction. Once training was curtailed, that lost experience could not be replaced at the front. The imbalance grew with every month. Allied pilots crossed Germany in enormous formations, protected by long-range fighters and supported by an expanding maintenance network. German replacements entered this environment with fewer hours to master navigation, formation flying, gunnery, and emergency procedures. Fuel scarcity had converted time into an Allied weapon. The same logic reached armored units. A panzer division was not a static collection of tanks. It was a moving network of recovery vehicles, trucks, workshops, radios, ammunition carriers, and fuel columns. Its striking power depended on all of them advancing together. A shortage at one distribution point could immobilize vehicles that remained mechanically sound. Movement orders became calculations of distance, consumption, and uncertain resupply. Commanders preserved fuel for operations considered decisive. That conservation reduced training and routine mobility, leaving crews less prepared when the decisive moment arrived. In December 1944, German forces attacked through the Ardennes. The plan sought surprise, rapid penetration, and the seizure of bridges across the Meuse. Speed was essential. Yet the offensive began under severe fuel constraints. German planning included the expectation that advancing formations could capture Allied fuel stocks. That was not merely opportunism. It exposed the weakness beneath the operation. An offensive designed to recover strategic freedom partly depended on taking fuel from the enemy it was supposed to defeat. Some Allied dumps were captured, and German vehicles used seized supplies, but captured fuel could not create a dependable distribution system. Columns still faced congestion, demolitions, resistance, mechanical failures, and air attack when the weather cleared. When spearheads stalled, their fuel requirements did not disappear. Vehicles idled, detours lengthened routes. Recovery and supply traffic competed for narrow roads. The German advance was checked by many forces, including determined Allied defense and operational decisions on both sides. Fuel shortage was not a solitary explanation for failure. It was a major constraint that made every delay more dangerous. This was the strategic consequence of the repair cycle at Leuna. The plant's lost output did not translate neatly into one abandoned tank. For each ton missing, scarcity distorted decisions. Before tanks stopped, it reduced practice. It discouraged movement. It narrowed operational choices. It forced commanders to gamble on captured supplies and favorable conditions. The damage accumulated invisibly until a plan demanded more mobility than the system could provide. German leaders had once regarded synthetic fuel as protection against blockade. Coal lay within territories Germany controlled. Technical expertise could turn that coal into liquid energy. The assumption was logical but incomplete. Domestic raw material did not make the resulting fuel invulnerable. It merely shifted dependence from foreign oil fields toward a small network of complex plants. Leuna embodied that trade. Its enormous capacity made it valuable. Its interdependent machinery made interruption disproportionately powerful. Its repair teams repeatedly proved that destruction was reversible. The Allied response was to make recovery temporary. By the final winter, Germany still possessed coal, engineers, factories, and weapons. What it lacked was the uninterrupted system needed to convert those assets into sustained movement. The pipes at Leuna could carry fuel again. They could not carry back the training hours, transport capacity, and operational freedom already lost. Inside Leuna, the struggle became increasingly detached from normal industrial production. Repair was now a permanent campaign. Teams mapped ruptured lines, isolated damaged sections, and searched for components that could return one process to service. Some equipment could be patched locally. Other machinery demanded specialized parts that Germany could no longer supply reliably. Even when production restarted, it did so within a national network collapsing around it. Coal had to reach the works. Finished products had to leave. Replacement machinery had to arrive through a transport system absorbing attacks against bridges, rail yards, canals, and locomotives. The factory could not escape the condition of the country supporting it. This exposed the limit of measuring resilience through physical reconstruction. A repaired installation was not necessarily a restored system. Its output might remain restricted by electricity, feedstock, transport, or damage elsewhere. Fuel leaving Leuna might then wait for rail cars. A delivered shipment might reach an airfield whose operations had already been reduced. Each bottleneck amplified the next. The bombing also imposed a defensive economy around the plant. Anti-aircraft guns required crews, ammunition, communications, and supply. Smoke defenses consumed equipment and chemicals. Decoys demanded construction and maintenance. Damage control needed fire services, emergency utilities, and clearance teams. These measures reduced losses and sometimes misled attackers. They also demonstrated how one target could absorb resources far beyond its production workforce. Every defense represented a rational response. Collectively, those responses deepened Germany as scarcity. The Allied system carried heavy costs as well. Bomber crews faced dense anti-aircraft fire and German fighters. Cloud could hide the target until the final approach. Smoke obscured aiming points. Repeated missions meant repeated exposure. Many bombs missed Leuna and struck nearby settlements, agricultural land, and labor camps. The people below could not distinguish a campaign against industrial connections from indiscriminate destruction falling around them. Among those endangered were foreign civilians and prisoners forced to support the German war economy. Their presence complicates any simple story of industrial victory. The machinery served a criminal regime. The labor sustaining it often included victims of that regime. Allied planners evaluated output curves and target photographs. People on the ground experienced sirens, shelters, collapsing buildings, and the expectation that another raid would follow the repairs. This human cost does not invalidate the mechanism. It reveals what the mechanism demanded. The campaign worked through repeated disruption, and disruption spread beyond the intended industrial nodes. Nor did the results prove every theory of strategic bombing. Attacks on cities had not automatically shattered German morale or stopped armaments production. Factories adapted. Production dispersed. The German economy continued delivering weapons longer than many Allied planners had expected. Oil was different because it was not merely another finished product, it was an enabling resource. A shortage of rifles affected the number of rifles available. A shortage of fuel affected aircraft. Tanks, trucks, training, supply, recovery, and command decisions simultaneously that gave each missing ton consequences across several systems. By early 1945, those consequences were visible everywhere. German aircraft remained dispersed on airfields, but could not generate the operational tempo needed to challenge Allied control of the sky. Armored formations could still concentrate vehicles, yet their ability to maneuver was restricted. Transport shortages obstructed both military operations and industrial recovery. The feedback loop tightened. Less fuel meant weaker defense of plants and railways. Weaker defense enabled more attacks. More attacks damaged production and transport. Damaged transport delayed the repairs needed to restore fuel. No single broken pipe created that collapse. Thousands of interruptions accumulated until repair could no longer regenerate strength as quickly as the war consumed it. This distinction explains why Leuna matters. The Allies did not defeat German engineering. German engineers repeatedly demonstrated extraordinary restorative capacity. The Allies defeated the interval in which that capacity could produce a strategic recovery. They turned days of renewed operation into targets. They made reconstruction predictable. They forced the plant to spend its future rebuilding its past. Leuna could survive another raid as an industrial place. Germany needed it to survive as a continuous flow. By then, those were no longer the same thing. By the spring of 1945, the distinction between damaged and operational had almost lost its meaning. Leuna still existed. Workers still entered the complex. Repairs still restored isolated processes. But the plant no longer controlled the conditions required for meaningful recovery. Germany's transport network was disintegrating. Electrical supply had become less dependable. Replacement equipment competed with emergency demands from every direction. Allied forces were advancing from the west, while Soviet armies pressed from the east. The repair race had reached its final imbalance. Leuna needed skilled labor, intact utilities, incoming coal, replacement parts, outbound transport, and enough uninterrupted time to combine them. The Allies needed only another break somewhere in that chain. Post-war investigators found that repeated attacks had held the complex to a fraction of its potential output after the oil offensive began. That conclusion did not mean every bomb had been accurate. Most were not. It did not mean Leuna remained completely inactive after every raid. It repeatedly recovered partial production. Nor did it prove bombing alone defeated Germany. The loss of Romanian petroleum, Soviet advances, Anglo-American attacks on transportation, territorial contraction, and battlefield consumption all intensified the crisis. The strategic result came from convergence. Germany lost external oil while its synthetic substitute was repeatedly interrupted. It lost transport capacity while damaged plants demanded more shipments. It lost experienced pilots while fuel shortages restricted the training of replacements. It accumulated weapons while losing the mobility needed to employ them. Each pressure made the others harder to reverse. That is why production figures alone can mislead. Germany could count another completed aircraft without counting the training hours its pilot lacked. It could count another tank without counting the fuel column required to move it. It could record Leuna as repaired without counting how briefly the repaired units operated. The decisive arithmetic measured regeneration against consumption. Germany's forces were burning fuel, losing territory, and exhausting trained personnel faster than its damaged system could replace their effective power. Leuna became a factory for postponement. Its crews postponed another production stoppage. Its defenses postponed another accurate attack. Its improvised components postponed the failure of another process. These achievements mattered to people fighting for survival inside the complex. Strategically, however, postponement could not recreate continuity. When American troops reached Leuna in April, they encountered the remains of a plant attacked repeatedly but never erased. The ruins preserved the central paradox. The complex had survived as infrastructure while failing as Germany's dependable source of motion. After the fighting, investigators walked through the works, examined production records, questioned officials, and studied the damage. They found no single spectacular wound that explained everything. The explanation was cumulative. Repeated attacks had broken utilities and process connections. Repairs had restored them. New attacks had broken them again. Output returned too briefly and too unevenly to satisfy the demands placed upon it. The factory's resilience had encouraged repetition until resilience itself became exhaustion. Leuna later returned to industrial life under a different political order. Its post-war future confirmed that the site had not been annihilated beyond recovery. Given peace, resources, and time, complex industry could rise again. Those were precisely the conditions wartime Germany no longer possessed. The opening image therefore deserves a second look. A worker tightens the final connection on a replacement pipe. Pressure returns. A pump begins moving. For a moment, the repair appears to have defeated the raid, but beyond the plant, reconnaissance photographs are being interpreted. Another target assessment is forming. Elsewhere, locomotives, steel, electrical equipment, anti-aircraft ammunition, and trained labor are already scarce. The repaired pipe is not evidence that the system has recovered. It is evidence that the system must spend again merely to reach yesterday's starting point. Germany had built synthetic fuel to escape the geography of oil. It could turn coal into gasoline, but only through a concentrated network of machinery, transport, power, and human labor. Once that network faced recurrent disruption, technical brilliance could not remove its dependence on time. Leuna's engineers kept winning the repair battle. The German war machine kept losing the interval between repairs. That interval reached the runway as missing training. It reached armored columns as restricted movement. It reached headquarters as plans built around fuel that might have to be captured from the enemy, and it returned to the same repaired pipe, waiting beneath another formation of bombers. Leuna could be rebuilt. The flow surrounding it could not. In industrial war, survival is not the ability to rise once more. It is the ability to regenerate faster than the enemy can force you down. If you value documented stories about the hidden systems behind victory, subscribe for the next investigation.